Introduction and basic principle of thermoelectric air conditioner. Introduction. Thermoelectric air conditioning is a revolutionary technology that harnesses the Peltier effect to create cooling effect or heating effect using electrical energy. Unlike traditional air conditioning system, which rely on the vapor compression cycle, thermoelectric air conditioner utilize the thermoelectric effect to transfer heat. Simple. First, Peltier effect. The Peltier effect creates a temperature difference by transferring heat between two electrical junctions. Second, thermoelectric module. Thermoelectric module use the Peltier effect to provide efficient and reliable heating and cooling. And the last one, energy efficiency. Thermoelectric air conditioning system offer energy efficient cooling solution for various applications.
Hi, my name is Nurhazima binti Mahdi, and for my part, I will explain about schematic drawing of basic air conditioning system and schematic drawing of thermoelectric air conditioning system. So here is the schematic drawing of basic air conditioning system. So for their components are compressor, condenser, evaporator, expansion valve, refrigerant, fans, and thermostat. So let's see how the basic air conditioning system works cycle. So firstly, the cycle begins when the thermostat senses the indoor temperature has risen above the desired set point. So the compressor will start and pump the refrigerant through the system. The refrigerant enters the compressor as a low pressure and it will leave as a high temperature and high pressure. And that high pressure gas will flows into the condenser coil. So the outdoor unit's fans blows air over the condenser coil and releasing the heat absorbed from indoor, and it causing the refrigerant to condense into high pressure liquid. So the high pressure liquid will flow through the expansion valve, and the expansion valve will reduce the pressure of the refrigerant, cooling it down significantly as it enters the evaporator coil. So lastly, the cool and low pressure liquid refrigerant will enter the evaporator coil, and the indoor unit fans blows the warm indoor air over the evaporator coil. So the refrigerant will absorb the heat from the indoor air and it will evaporate the refrigerant into a low pressure gas, and lastly it will cooling the air in the system. So next, let's see the symmetric drawing of thermoelectric air conditioning system. There have 5 components in the thermoelectric air conditioning system, which are thermoelectric module, heat sinks, fans, power supply, and lastly control system. So for your information, the working cycle of thermoelectric air conditioning system is based on the Peltier effect, where an electric current is used to transfer the heat between the two materials. So let's see how the working cycle step. Firstly, the power application. When a DC electrical current is applied to the thermoelectric modules, the electron will move from one type of semiconductor material to another. The second step is heat absorption, as the electrons move from the P-type to the N-type material that absorb the energy in the form of heat from their surroundings. This heat absorption creates a cooling effect on the side of thermoelectric module. So, a heat sink may be attached to this side to enhance the absorption and distribution of the cool air. So, next step is heat rejection. The electrons will release the energy as a heat when they move back from the N-type material to the P-type material on the other side of module. And this side of module will become hot and the heat needs to be dissipated to the external environment. So the heat sink and fan are used in this site to facilitate efficient heat dissipation. The next step is heat transfer. The heat transfer is continuous as long as the electric current is applied. The heat is pumped from the cold side to the heated side. Lastly, temperature control. The system can be controlled by adjusting the input current to the thermoelectric modules, which regulates the amount of heat being absorbed and expelled.
Hello, my name is Muhammad Is bin Khairul Bahri. I will explain to you about the method of analysis performance. So, let's see how we analyze the performance. First, we need to know about the coefficient of performance, COP. What is COP? Okay, COP is the ratio of useful heating or cooling provided to the electrical energy consumed. As you can see, the formula of COP is COP equal to cooling capacity divided by energy consumption. This COP is very important to the performance because if we get high COP, the performance will be greater. So let's talk about the cooling capacity, QC. What is cooling capacity? Cooling capacity is the critical parameter that measures the amount of heat that the system can remove. And next, we talk about energy consumption. Energy consumption is to analyze the power consumption in relation to the cooling output. So as you can see, the formula of these two cooling capacity and energy consumption is different from the general air conditioning because we use the circuit thermoelectric. So in this formula, we add current, resistance, and Seebeck effect. Next, we will talk about temperature differential. What is temperature differential? The temperature differential directly influences the heat pumping capability of the thermoelectric module. The higher difference of temperature generally indicates a more significant cooling effect. Is it related to the performance? Yes. Okay. The difference of temperature increase, the effectiveness of the Peltier effect decrease. So it will reduce the COP. If the COP drop, the performance will drop. So temperature differential is related to the performance. If we want to get a higher COP, higher performance, we will decrease the temperature differential. So next we will talk about type of material. What is type of material? Type of material is responsible for converting electrical energy into a temperature differential through the Peltier effect. So the materials with high figures of merit, ZT, will provide better performance.
Hi everyone, my name is Hong Hui Sing with matrix number B0422100063. Today I will share about performance calculation in thermoelectric air conditioning system. We have three main formula we'll be using, that is QC, cooling capacity, ZT, figure of merit, COP, coefficient of performance. In simply word to conclude, ZT is the material efficiency in converting heat to electricity. QC, measure how much heat the cooler can move. COP, measure the overall efficiency of the cooling process. So now, let's put value inside formula of QC. After calculation, we will get QC is equal to 36.16 watt and the COP will get 0.3013. Next, let's calculate about figure of merit, that is ZT of the system. After calculation, we will get the ZT is equal to 0.01. So now, how about if ZT increased to 0.02? After calculation, we get the new value of QC, that is 331.68 watt, and new value of COP, that is 2.764. This comparison clearly showed that even a small increase in ZT can lead to a substantial improvement in both the QC and COP of the system. The higher ZT value means better material properties, such as a higher seatback coefficient, better electrical conductivity, and lower thermal conductivity, which collectively enhance the performance of thermoelectric device. In summary of performance calculation of system, advising the ZT of thermoelectric material is important for making this system more viable and efficient. With ongoing research and technological improvement, we can expect
there are three points, which is the first one is enhancing material properties. We use higher electrical conductivity materials to reduce resistive losses. Then, optimizing the seatback coefficient, which is seatback coefficient in terms of thermodynamics correspond to the amount of entropy dragged along to the flow of charge inside a material. By select materials or modify existing ones to have a high seatback coefficient, or develop materials that can reduce thermal conductivity to maintain a significant temperature gradient. This helps for a temperature cannot be released to the surrounding. The second point is optimizing device design. Improve heat dissipation on the hot side of the thermoelectric module to maintain a higher temperature differential across the device. Design the module configuration to maximize surface contact and minimize thermal resistance. The last point is band structure engineering. Doping. Introduce dopant to optimize carrier concentration and mobility, balancing the electrical and thermal properties. Doping is a process where impurities are intentionally introduced in the material to alter its electrical properties. That's all. Thank you.